There are over 170 unique names for modes of mechanical ventilation. Even though there are over 100 names for modes of mechanical ventilation, there are only 20 unique modes. Which mode or modes of ventilation do you use? Is it based on the technology available on your current ventilator platform? Is the mode of ventilation you primarily use based on personal bias? Why not select a mode of mechanical ventilation based on the 3 primary goals of mechanical ventilation? These goals include patient safety, patient comfort, and liberation from mechanical ventilation. Welcome to What's Your Mode? In What's Your Mode, I'll be discussing 18 different modes of mechanical ventilation and how they meet or don't meet the goals of mechanical ventilation.
What's your mode? Volume Control-CMV set point targeting. Volume Control-CMV with set point targeting is probably the most used mode of mechanical ventilation. Using the ventilator mode map application, you can change the mode tag to VCCMVs and see the various ventilators and vendors that have this mode of mechanical ventilation. Here are examples of the many names for Volume Control-CMV with set point targeting. Here are the 3 goals of mechanical ventilation. Let's look at each in more detail. First, safety. Within safety, there are 2 main objectives. One is to optimize the ventilation perfusion of the lungs, and second, to optimize the pressure volume curve. Optimizing the ventilation perfusion of the lungs, there are also 2 aims. One aim is to maximize the alveolar ventilation. The second is to maximize oxygenation. I will not be talking about this when selecting a mode of mechanical ventilation because pretty much all mechanical ventilators allow for the manual manipulation of FiO2 and PEEP. However, outside the US, there are some modes of mechanical ventilation that automatically adjust the FiO2 and PEEP. Maximizing alveolar ventilation. Does your mode allow for the manual adjustment of minute ventilation parameters? Second, does your mode allow for the automatic adjustment of support in response to changing respiratory system mechanics?
For this example, I'm going to use my Hamilton Medical G5 ventilator simulator. And for our volume control CMV set point, I have it set up for CMV. So this is what the Hamilton simulator calls it. And I'm going to look at my controls here. Now, does VCCMV set point allow the operator to manually adjust minute ventilation parameters? And yes, it does. I can adjust my tidal volume. I can increase this or decrease this, as well as my respiratory rate. Volume control CMV with set point targeting does allow the operator to manually adjust the minute ventilation parameters. However, does it allow for automatic adjustment in support in response to changing respiratory system mechanics? Well, let's find out. To achieve this capability, there are some features with certain modes of mechanical ventilation where it lets the ventilator actually set the inspiratory pressure to achieve the target tidal volume. So here's my example. We have the tidal volume, which was mainly inputted at 500 cc's or milliliters. And what should happen is the pressure should go up or down to achieve this tidal volume safely. And when I change my compliance or resistance, my respiratory mechanics, does the ventilator breath by breath automatically titrate the pressure up or down to achieve this goal? So I'm going to switch my patient to ARDS patient. I'm going to go back to switch to normal because the waveforms and measured values already took off. And I'm going to switch the patient again. We notice that we have a starting peak inspiratory pressure of 15. And when I do this, it's going to change compliance. And as you notice, you can see the waveforms. The next immediate breath, my pressure is 24. So that's immediate response. That's not the ventilator in between breaths adjusting my pressure to maintain this tidal volume at all. So volume control CMV with set point targeting does not have the feature or the capability to allow for automatic adjustment of support in responses to changes of respiratory system mechanics.
In regards to optimizing the pressure and volume curve, the aim is to minimize the risk of volume trauma. To minimize the risk of volume trauma, does your mode allow for the automatic adjustment of lung protective limits? And does it allow for the automatic adjustment of tidal volume?
Does volume control CMV with set point targeting have the capability or the abilities to minimize the risk of volume trauma? So one scenario, one example would be, does it automatically adjust lung protective limits? And the example I'm going to use is something to prevent dynamic hyperinflation or auto-PEEP. And would this mode actually change my respiratory rate or my IE ratio based on my measured respiratory rate or my lung mechanics? So what I'm going to do is I'm going to have the patient now spontaneously breathe, and I'm going to increase my effort from 0 to, let's put it at 15, make him vigorous. And this should be a respiratory rate of 35. My patient's starting to spontaneous breathe. You can see it in the lung tool here. You can see the diaphragm move. You can see in the waveforms. And my measured values are going to start to pack up. And if we notice from the waveform is I'm barely fully exhaling. So there's an incidence of, or evidence, sorry, of some auto PEEP there. And then if we look at my measured values too, here we go. I have my auto PEEP now of 0.2 centimeters of water. So even if the patient's rate increases a little more, it does not change the respiratory rate at all. It doesn't change my IE ratio or my inspiratory time. So my lung protective limits are based on operator input. So it does not allow for automatic adjustment of these parameters. Now, does the mode allow for automatic adjustment of tidal volume if the patient's respiratory mechanics change? So I'm going to have my patient, what happens is let's change it over. I'm going to change it if you're ventilating me approximately at 8 cc's per kilogram of ideal body weight. So say I was a normal surgical patient, you're giving me around 8 to 10 cc's. However, I get sepsis, get an infection from the surgery, and now I get ARDS. So I have ARDS and my lung mechanics change. And I change that over. And ideally, I should be ventilated around 4 to 6 cc's per kilogram of ideal body weight. However, there was no automatic adjustment of tidal volume at all based on my lung mechanics, based on my physiology of my lungs. It remains around 8 cc's per kilogram of my ideal body weight. So volume control CMV with set point targeting does not allow for automatic adjustment of tidal volume.
With our second goal of mechanical ventilation, patient comfort, our main objective is to optimize patient ventilator synchrony. With optimizing patient ventilator synchrony, we also have 4 aims. The first is to maximize the trigger and cycle synchrony. Second, maximize flow synchrony. Third, coordinate ventilator output with patient demand. And fourth, minimize auto-PEEP.
Does your mode allow for the coordination of mandatory and spontaneous breaths? Are all breaths spontaneous with patient effort? And is trigger or cycle based on signal representing chest wall or diaphragm movement?
Does volume control CMV have the capabilities to maximize trigger and cycle synchrony? Let's look at one capability. Does the mode allow for coordination of mandatory and spontaneous breaths? And I'm going to have the patient now spontaneously breathe. I'm going to have a rate of 10, and I'm going to increase the effort to around 10 centimeters of water. And we're going to look at the waveforms here, and you'll notice that there's my assisted breath, here's my spontaneous effort, and my spontaneous breaths are for the same inspiratory time as the mandatory breaths with the same tidal volume also. So it does not allow for a coordination of a mandatory versus a spontaneous breath. My patient can't take a longer breath if they want to, or take a shorter breath. It's the same inspiratory time as the mandatory breath. Another feature that we can look at to see how synchronous a mode is once the patient starts triggering breaths, are all the breaths spontaneous? And as you notice here, they're not spontaneous. They're still for a certain amount of time. Is the patient trigger and cycling based on a signal representing chest wall or diaphragmatic movement? And no.
Does your mode provide unrestricted inspiratory flow?
Does volume control CMV with set point targeting allow for unrestricted inspiratory flow? Now, with these mandatory breaths, we can look at our measured inspiratory flow. And here's my inspiratory flow measurement of 24. Now what I'm going to do is I'm going to change my patient's inspiratory drive. I'm going to change the effort. I'm going to change this to 15, and let's see what happens. And with these spontaneous breaths, these inspiratory efforts, the patient has a high inspiratory flow demand. You notice that my flow is fixed. So for volume control, CMV with a set point targeting scheme, it doesn't allow for unrestricted inspiratory flow.
Does your mode allow for automatic adjustment of support to meet patient's demand? And does it automatically adjust the support to maintain a specific breathing pattern?
Can volume control CMV with set point targeting adjust the amount of support based on the patient's demand? And we'll see, here's my measured tidal volume value, and my measured inspiratory flow, 24. And I'm going to just increase my patient demand. So say my patient gets very agitated or is in pain, or metabolic rate changes dramatically or increases dramatically. As you notice, I changed this, and my patients get more vigorous. However, my tidal volume does not change, my inspiratory flow rate does not change. Or if my patient goes to sleep, my output remains the same. I'm having the same tidal volume and the same flow rates. So it does not. Number two, does it maintain a specific breathing pattern? We need a signal input as an Untitled CO2 device to maintain a specific breathing pattern. So volume control CMV with set point does not have this capability either.
Can your mode automatically limit auto peep?
Can volume control CMV with set point targeting limit auto peep? Let's find out. So I'm going to change my patient to a patient with COPD. So I'm going to make it more obstructive. And this should create some dynamic hyperinflation. And if we notice our auto peep measurement here in the lower left hand corner, that I have an auto peep of 0.2 centimeters of water. So volume control CMV with set point does not prevent auto peep or limit auto peep.
Regarding the third goal, liberation, can we optimize the weaning experience? Does your mode provide an automatic reduction in support in response to increased patient effort? Does it allow for a ventilator-initiated weaning of support? And does the ventilator recommend liberation?
Does volume control CMV with set point targeting facilitate liberation from mechanical ventilation? Now, does the mode provide an automatic reduction of support in response to patient effort? And as we can see, when we look at my patient, I actually have my patient spontaneously breathing with a rate of 10 and a patient effort of 10 centimeters of water. And as you notice, The machine is still going to deliver its backup rate of 12 breaths per minute, and it's still going to deliver 500 cc's or milliliters no matter what. So it doesn't have this feature. And does the mode actually initiate any weaning of support? And as you can see, it does not. And lastly, does the mode recommend liberation? And the mode in no way recommends liberation.
Volume Control-CMV with set point targeting is a simple to use mode of mechanical ventilation. However, in regards to the goals of mechanical ventilation, it has little to offer. The main advantage is with this simplicity during the acute phase of illness or during surgical procedures, the operator can manually adjust the minimum minute ventilation parameters. However, after this acute phase of illness or after the surgical procedure, there is no clinical benefits. It provides no comfort or does not optimize the liberation experience.